Okay, I will start over again for this example one because it's suddenly closed. Okay, for the example one, a contractor agreed to hold the solid wastes from an industrial district of a city, and the industries agreed to store their wastes on large containers located at strategic points. And due to the sizes of the containers, the whole container system of collections to be used based on the traffic study, T1, T2, and D1 were found to be 20, 25, and 8 minutes respectively. And if the round trip whole distance average 60 km at the speed of 55 mph, for many containers can be serviced on a collection day of 8 hours. So based on this question, we supposed to have several assumptions to complete this question. So for the solution, I will share to you the solution sheet. Okay, these two formula you need to use to complete this question. We have T net equals to M plus 2 plus weight D1 plus weight S plus weight H. And for NT, 1 minus weight W plus the bracket multiplied by weight H minus weight T1 minus weight T2 divided by T net. And then the assumption that you need to have small w 0.15 and M plus U, which is 0.4 hours per trip, and S equals to 0.133 hour per trip. And then for D1, T1, and T2, you need to convert become the hours. Like 8 minutes become 1.33 hours. 20 minutes becomes 0.333 hours. T2, 25 minutes becomes 0.417 hours. And for H, small h, which is full time, 60 kilometer per miles hour, you need to convert become only hours. So you can get 0.676 hours. And you apply T net, which is from this formula, M plus U plus with D1 plus with S plus with H. So you just put all those values there, and you can get 1.34 hours per trip for T net. And then for NT, you need to apply this formula, which is 1 minus with W plus the bracket, and then multiply by big H minus with T1 minus with T2 plus the big bracket divided by T net. So you just put all the values there for this unit, for this symbol, and then you can get 4.5, or it went close to 5 trips. So the numbers of the container can be services by the 8 hours of collection day, which is only 5 number of containers or 5 trips only. So we proceed to the next one. SCS. SCS, which is the container is emptied into collection vehicles at the point of the collection. And you can see from this diagram how the SCS looks like, which is they need to complete all the areas, and then afterwards they need to hand it towards the S, which is transfer station or processing station or disposal site. Based on this SCS, the container is emptied into collection vehicles at the point of the collection, and there are generally two types, which is the container are large and must be emptied by mechanical means, which is they have a wheel residential pickup and commercial pickup. And the next one, the container are small and can simply be emptied manually, which is used by the handy person. An example for this SCS, solid waste are collected from apartment buildings, large commercial establishment, and public parks, which places are stored in large containers strategically located in the premises. And another example, which the collection in residential areas. So this one applied for SCS. Okay, almost all vehicles contain the internal compaction equipment because they will carry the much numbers of the wastes. The advantages for this SCS, actually vehicles does not travel to disposal area until it is full, yielding higher utilization rates. And disadvantages for this system is not flexible in terms of picking up bulky items. And for example, like for demolition, will make damage which relatively delicate for mechanisms type of this vehicle. And then high volume generation may not have the high volume of generation may not have room for storing the large containers. Okay, based on these figures, figure 4.3 shows the schematic diagram of SCS. And let the number of container location in SCS be C1. Also, there's no M and U, no mounting and no unloading in the SCS, because they will accomplish it in one trip. Instead, there is the time to pick up and load the solid wastes from the container location to the collection vehicle, which is the small p. And using the same meaning for D1 as ACS, Tnet is Tnet equals to P plus D1 close the bracket multiplied by C1 plus Vs plus Vh. As mentioned, D1 is the average between the container location driving time per college per container location. And the average driving time between the container location known as DBC. If there are C1, which is the container locations, the number of driving distances in the collection route is C1 minus V1. And the total amount of the time spent driving in the collection route is TBC multiplied by C1 minus V1. Hence, T1 equals to DBC, open the bracket, C1 minus C1, close the big bracket, and then divide by C1. And number of trips NT equals to 1 minus VW multiplied by H minus with T1 minus with T2 divided by Tnet. And the value of P and D will vary based on the system either mechanically or manually loaded. In mechanically loaded system, P could be as low as 30 seconds and DBC can be as low as on the order of half minutes. So for the mechanically, we apply for the second. Another factor to be considered in SCS, the dimension of the size of the collection vehicle must be sufficient to hold all wastes on a trip. If VD is the volume of the refuse as discarded, VD discarded volume in one trip or collection route, and R is the compaction ratio, the required volume of the vehicle, VH, is VH equals to VD over R. If the total discarded volume of the solid wastes on collection day is VDC, the total number of trips is also given by NT equals to VDC over VD or VDC over VH multiplied by R. Example 2. In an on-site time study of mechanically loaded SCS, the time it takes to empty all location in collection rate is 2.32 hours. The average driving time between container location is 0.1 hours. If there are 11 containers, calculate P and D1. So for mechanically loaded means that they need to use second. So this one need to convert for second. So I will share to you the solution sheet. Okay, this one you need to find the P first. P equals to 2.32 divided by 11, which is 11 containers. And you can get 0.21 hours. For D1, equals to DBC multiplied by C1 minus C1 divided by C1. And for DBC, you can get from the question, this is 0.1 hours. multiply by 11 minus 1, close the bracket, divide by 11, so you can get 0.09 hours. So I will proceed by the next slide. In on-site time study of a manually loaded SCS container, the time it takes to empty all locations in a collection route is 2.32 hours. The average driving time between container location is 15 seconds, which is DBC equals to 15 seconds. If there are 270 residences serviced in one collection route, calculate P and D1. Okay, so they use the 50 seconds, so this one need to convert 4 seconds. And this one we use the hours, so we just maintain the hours. We just those applied for mechanically loaded. Okay, for this, we continue for this one. So this one for C1 and this one DBC. So I will show you the slide. Okay, 2.32 hours need to convert to second. 2.32 hours multiplied by 3600 seconds, which is equal to 1 hour. You can get 8352 seconds. And then T equals to 8352 seconds divided by 270 residences. And you can get 30.9 seconds, which is equals to 31 seconds. And then for D1, DBC multiplied by C1 minus C1 divided by C1. So 15 hours for DBC, can get from the equation. And 270 residential residence minus 1 divided by 270 residents, can get 14.9. And then you can round off, it will become 15 seconds. Okay, the solution actually the number of collection for locations equals to number of residences. So that's why we use the C1 as 270 residences. Proceed by our slide. So for example 4, a total of 11 apartment complexes and commercial establishments have entered into a contract with a solid waste collection firm to collect their solid wastes. The discarded volume of solid wastes to be collected is 96 cubic meter per collection day. And determine the number of trips required on the collection day, the size of the collection vehicle, and the size of the container to be provided. So the three things that we need to find: number of trips, size of the collection vehicle, and size of the container. Assume R, the ratios 2.5, and for simplicity, assume that each of the 11 sources contribute the same amount of solid wastes. Make any assumptions which necessary. So the assumption we will use the same like the PCS. So we share the slide. Okay, based on this example 4, the assumptions that I made, DBC equals to 0.1 hour, T equals to 0.2 hours, S equal to 0.1 hour, and W equals to 0.15, big H equals to 8 hours, T1 20 minutes will change to the hours, which is 0.33 hours, T2 25 minutes will become 0.417 hours, and for the H, small h, round trip or whole time, which is 60 km at speed of 55 miles per hour, so you can get 0.676 hours per trip. And then for the solution, D1 equals to DBC multiplied by C1 minus C1 divided by C1. So DBC here, which is 0.1. Open the bracket 11 minus 1, close the bracket divided by 11, so you can get 0.09 hours. For TNET, P plus D1 close the bracket, multiply by C1 plus Vs plus Vh. So you can get 3.966, which is approximately towards the 3.97 hours per trip. And then NT, which is for the number of the trip you can get, 1.1 minus VW multiplied by BH minus T1 minus T2 divided by Tnet. So you just put all the values there. You can get 1.52 or nearest to 2 trips. So now we already answered the first question there, the number of the trips needed, which is 2 trips. Okay, so based on these 2 trips, we need to find the size of the collection vehicles. So we use this value VH equals to 96 cubic meter of the solid waste on the volume of the discarded of solid waste being collected, which is 96 cubic meter. We will divide by 2 trips and then we will divide by our R, 2.5. So you can get 19.2 cubic meter of vehicle size. And then for the volume of the containers, 96 cubic meter divided by 2 is our trips, and then divide by total of the collections container, which is 11. So you can get 4.36 cubic meter. And this one, the numbers of this one, the volume of the containers. So for this question, you need to link with the formulas that given. That is why VH equals to VD over R. That's why we applied for the discarded volume over the R based on the number of the trips. We proceed by this one, the routes of collection. Okay, the routes of the collection, just the guideline that should be taken into consideration when design the layout of the collection routes, because this one make it the easiest for the drivers for targeted for the collection purposes. And then this thing must apply based on the existing policies and regulations, existing system characteristic. Begins and ends should be near arterial street to avoid the traffic jam. In hilly areas, so what it is that supposed to be, the last container to be collected must be located nearest to the disposal site because the last places to be collected and traffic congested locations, so this one need to be addressed. And then sources are the extremely large quantities and then scattered pickup points. Okay, for the existing policies and regulation, which is applied for the number and arrangement of the containers, frequency of the collection. Existing system characteristic, which is they apply for the number of the crew and also the vehicle type, which is either the standard or standardized garbage truck will be used. And begin and end should be near arterial street because easy to access or easy to transporting the wastes towards the transfer station or any other centers. And in hilly area condition, it should start at the top and proceed downhill as the vehicle become loaded. And the next factors, which is the last container to be collected, must be located nearest to the disposal site because the last location. So that's why it must be near to the disposal site or nearest to the transfer station. And then for the traffic congested location should be collected as early in the day because to avoid the delay. And sources at the extremely large quantities serviced during the first part of the day because they're just too huge. And scattered pickup points, the number and arrangement of the containers must be determined. And the distance between the containers also must be close located. Number of the blocks and arrangement must be have in the schedule for the collection purposes. The next one, layout of the collection routes, is generally steps involved in establishing route in which include the preparation of location maps, data analysis, primary layout of the routes, evaluation of evaluation of the primary routes, and the development of balanced route by successive trials. And based on this layout, also some form of geographic information system (GIS) is now used to identify each customer's location. And a variety of other complementary programs have also been coupled to the GIS to both optimize the collection process and to improve the service provided. So we just add more system for this solid waste management to make it more easier for the collection. Okay, the first just here for the preparation of location maps, which is on a relatively large scale map of the area to be serviced. The following data should be plotted for each solid waste pickup point by the location, number of containers, and collection frequencies, which is might be twice per week or every day. If a stationary container system with self-loading compactors is used, the estimated quantity of wastes to be collected at each pickup location. And the second point, which is prepare data analysis or summaries, which is it estimates that the quantities of wastes to be collected from pickup location serviced each day that the collection operation is to be conducted. And where a stationary container system is used, the number of locations that will be serviced during each pickup cycle must also be determined. Okay, the next one, primary layout of routes. Layout primary collection routes starting from the dispatch station or where the collection vehicles are parked. A route should be laid out that connects all the pickup locations to be serviced during each collection day, and the route should be laid out so that the last location is nearest to the disposal site. So this is the function for the primary layout of the routes. And the next one, development of balanced routes. After the primary collection routes have been laid out, the whole distance for each route should be determined. Next, determine the labor requirements per day and check against the available work times per day. In some cases, it may be necessary to readjust the collection routes to workload and distance traveled, because this one might be being changed because of the traffic, or might be because of the accidents that happen during the route or during the collection. And the next one, after the balanced routes have been established, they should be drawn on the master map, the big one. And then the schedule for the collection. Master schedule for each collection route should be prepared for use by the engineering department and the transportation dispatcher, because they only from those department they can have the existing layout or the current layout for the route, including for the construction route and also the closed route. Schedule for each route should consist of location and order of each pickup point to be serviced, which is prepared for driver, and route book should be maintained by each truck driver, because they need to know where they need to start first and then where they need to end afterwards. So this is all about the collection services under the solid waste collection management. If there's something that you doesn't understand, you can just ask me in the WhatsApp group. That's all for today. Thank you for listening, and thank you